bikes and televisions, as you can see in the back, even an old Cessna airplane. He was able to process. It took him a year, but eventually he did. And he died of natural cause 2 years ago. So I guess that's like that's a bit of the evidence that this should be a good approach. His way of doing this was grinding it up to like the finest dust and just putting it in his food. I think he ate a kilo of steel every day, something like that. Okay, so my story starts half a year ago when I came to work for Leonard. That was my first experience with Objective-C, which was actually a nice one. I come from a Java background for the C, C++ stuff, and I was delighted to see all these calls I could make. You can just take a URL and ask for the data, and bam, there you have it. And this data object. You can manipulate, you can get a pointer to the internal data. Same for strings. You can get a dictionary out of a file. Maybe send a request to a server, though generally people are not really in favor of doing synchronous requests. This is just an example. And even a scanner on top of a string. So most of the time, one call and you have the data you want. That works pretty well for most apps these days. iPad apps are still pretty small. Until came along a client who needed an app with a few specific properties. One of them is we need to handle big files. We're talking about megabytes, hundreds of megabytes even in an extreme case. Something you cannot easily hold in memory, but the iPad is capable of handling in general. Another request was files need to be stored on the drive, on the internal memory, but it needs to be encrypted. So no storing of the plain file data. And last one, could you also upload it and download this from the internet? But it seems like pretty natural requirements on an app. But all the good things I saw, or I learned about Objective-C, they kind of fell apart. There's no retrieving data from the URL anymore because from the file URL because it's too big, it doesn't fit in the memory. There's no just getting a pointer to this data because it's encrypted. So you have encrypted data, but you can do anything with it. And if you want to upload this file, you can just simply say, here's your HTTP request body data. It doesn't work like that. So we had to come up with another approach. And that was mostly just like, starting to write it, just throw in some crypto calls and see if you can glue it all together. And eventually we kind of managed to do this. But what grew out of this was a system that doesn't just use standard data string manipulation stuff that you find in Cocoa, but more of a stack that we build up. So you don't just read the file, though you have kind of a handle to this data, and then you start your file, you have a reference to it, you pull it through some crypto to get the original file data. And then, well, if you want to render it, you have to convert it to CG data provider. I assume people are experienced with that. Well, anyway, it's a way to in general to render things with core graphics. But also, if you want to stream it to a server or maybe download it, then you first have to get it processed in a streaming fashion. Maybe you want to have some progress information, how your file is doing, if it's halfway the upload progress. And eventually, you have to put it in a stream, because that's the only thing that NSURL connection has. Okay, you can of course always start to play with sockets and things like that, but if you want to use the standard request, HTTP request, then you need a stream for this. But it was quite an adventure to find this out. You start just improvising with these without it. And for people that have Java background, this is quite a common thing to do in Java, where you just pile these things on top of each other, where you chain one operation after the other in order to move from, well, for example, an encrypted file up to uploading it to a server. Is this kind of like clear what I'm trying to explain here? It's not just the data, it's really about handling the access to the data. And then,
the thing I don't understand is that you decrypt it and provide it on your screen, and you also decrypt it before you send it over the internet. Or is it
yeah, we use HTTPS for that.
Okay.
HTTP is HTTPS.
So you decrypt it and then you encrypt it again?
Yes, well,
Why?
well, good question.
The encrypted part is for the user.
Well, yeah, but you could of course also just send this file encrypted, right? So yes, indeed, then you can take out the encrypted part, but still you need a way to send a big file through this URL request, and so you need this conversion software. Yes.
If you just send your own decrypted files to the internet, somewhere on the server, someone would need the key for decryption of your file.
Yeah.
So your decryption key wouldn't be private anymore.
Yeah. Yeah.
So I think it's reasonable that you decrypt and then recrypt for the server.
Well, thanks. You guys should talk. Yeah, so it's this is also kind of like a search for the easy way to do this, because we want to use all this handy Cocoa stuff, but as you start poking around in these systems, and you go beyond standard data or standard string, bigger files, crypto, for example, is not something you're supposed to do. Apple says no, we do it. You just keep it simple. But we're stupid, so yeah, we have to. And then you find out that it's harder, but it's definitely doable if you when you build these kind of interfaces with Cocoa. So the interface to the HTTP, to the CG data, and to the file system. Well, yes, the app is almost ready, I should say, and it all works. But it's kind of a proof that this kind of stuff is possible and it performs. But it's also proof that our approach, I think, has been pretty successful in that you don't just start hacking together, but instead try to compartmentalize the problems, modularize them, and stack them on top of each other. And I was quite happy with that. So I thought, well, maybe it's something I have to share with the world. And redo the whole thing, because there were small problems here and there. Try to make it nice into a framework. So I did. Just short overview. It consists of sources, which are ways to access all kinds of primitives like data, strings, files, streams, and a way to connect the framework to all the primitives that are the data that's already present. Here you see an example how you create a stream from the URL. Filters, which allow you to monitor data that comes through, so it's kind of a chain. You can chain these operations together from a source via a filter, by another filter, again towards the source, which is a seek in that case.
That's the question. Since this is a, let's say, an operation where you stack up functionality on top of functionality, would it be possible for me to, let's say, plug in some kind of functionality of my own in there?
Yes.
For example, I get a big chunk of XML, I want to transform it using a plugin and then do something with it.
You want to process the XML streaming.
For example.
Yeah, indeed. I must say that currently I only have a byte support, so no character encoding, and that's what comes with these textual formats. But indeed, that would be possible. It's actually something I would really like to build at some point, a streaming XML library. That would be great, right? But indeed, it's also
the difference between filter and transform?
Well, the transform is a filter, but a filter is not a transform. And it's filters. Well, transforms are an easy way to build these things. So you could just write your custom filter that just does something with the data. But I made it easier to do this using transforms, which are not. They have more basic implementation. And
I suppose a filter doesn't change the data, or does it?
yeah, you could say that. Yeah, I don't think I have filters that change data. So yeah, maybe that's a nice rule for this. But they don't take anything out as well, which normally a filter does. Right? So then there's extracts, and that just monitors the data that comes through and derives something from it. For example, a checksum, the SHA-1. Okay. Is there anybody who ever felt the need for this and thought like, hey, isn't it there? Or maybe thought like, oh, well, I already built this. What are you doing? It is, of course, something that only comes in handy if you have to deal with stuff that really needs to be processed in a chat way. If it's just a big block, you can just first encrypt it, then send it as a HTTP body over the internet. But yeah, I hope it's something that especially as the iPad becomes more stronger device, more powerful, and larger data processing tasks have to be performed here. It might be of use, actually. So, about sharing it, I put it on GitHub today. Also, so people can read this blocky code. And it's a standard Xcode project. Just download it and get going. There's demos in there, there's tests in there, there's even documentation. And
what's it
if
called?
something's missing, I would be very happy to add it.
What's the name of this whole thing?
Well, that's a good question, actually. I didn't come up with a good name, but I call at the moment I call it NW, which stands for Noodle Work, IO, which stands for input, output, something like that. Let me just show on screen. There it is. Okay, right? So is there any time left maybe for so I can show a few code snippets?
Yeah.
Just to get an idea, because it's all very abstract. At least that's what I hear when I try to explain it to people. Yeah, it's interesting, but I don't really know what the use is.
What's the kind of data you were using this for? Or can you not share it? You're not allowed.
No,
We're using it for PDF. Big data. On the preferences scale presentation modes that we also have.
yeah, weet ik. Wait a second. Okay.
Actually, yeah, so we use this for PDF, so we also have to render it to the screen from encrypted in disk. So there's we have this PDF framework from Apple. So we have to put some custom thing between for encrypting data while going through the PDF. And the same for uploading stuff we just said.
Yes.
And if you see the app, it's basically a PDF reader, but there's stuff going on.
Yeah.
Does it go both ways? Can you also create PDFs with it? Because you said something about uploading, and I'm trying to figure out the uses of uploading data that comes with the app itself.
That's actually what this whole app is about.
Yeah.
Okay.
The server manipulates this PDF, and so you download it again. Sorry? The server changes the PDF, and then you download it.
Okay.
Okay, yes, I was about to give you a small demo. made this app, which is kind of a console, but we can show it in the iPad later on, and a few demos that show different parts of it. For example, if you want to deflate, like the deflate settling compression algorithm, you can simply do that by creating a deflator stream and give it some text. This is just a string, so you say init with input string. I know like it's not a realistic case because strings would be too big to keep in memory, but it has also lots of debugging facilities. One of them is just using a string as an input. And then, well, in this case, we don't want to deflate, we want to inflate, so I invert it. That's what happens here. And that's actually all you need to do to create a full deflation algorithm. To use it in a very Objective-C Cocoa way. So then you'll ask, of course, where is the data actually processed? Well, that's not that important, right? It's all about the configuration and setting it up. And then once the data is really needed, you can start pulling it through as much as you need until the end. That's necessary. So another example had to upload some data to a server. That's what I'm doing here. Here I'm sending some random data to MySpace. So I create a random stream with a few kilobytes length. That's what happens over here. Then I create a multi-part stream. As you might know, multi-part form data is composed of some stuff in the top. Let's call it a header, which refers to the file, then the body, and then an endnote. Well, it's really hard to do this in Cocoa. You have to compose the stream yourself. Then you have to first read some from this header, then read the whole file, and then read the final part. This is all done for you in this multi-part reader. So you just say, like, okay, the name of the file is random, create a request. I say, like, configure this request so it takes the data from this stream, and then you send the request. In this case, synchronously, I'm sorry, to the server. So there's ways to count the amount of data that comes through, to show progress bars, to do crypto. But they always say don't draw your own crypto, so I didn't do it.
Do you have an example with asynchronous communication? Because like it defeats, like having a synchronous request there basically defeats all the purpose of that, right?
Yes, well you can just replace this with send synchronous, send async request.
Do you have an example? How do you fit your framework into? How do you plug your framework into an asynchronous?
Okay, so let me just copy this. I have an empty demo lying around somewhere. Yes. It's always tricky doing this thing, but it'll work. Okay, yes. Now, we have the request, right? The request contains everything. It contains the method, HTTP method, it contains the stream, which it reads from, which is actually a composite with the file data, the random data in this case inside. And now you can just say URL connection with request, and then there's a delegate we say self, right? And I believe it already starts.
Yeah, you have to call start, and then you have to like.
And then we need to add delegates, delegate methods.
So you don't have a basic delegate, some kind of class that implements some delegates methods to plug with your stuff.
Oh, no, yeah, that's okay. That's the short answer. No. Um, nature of this library is very similar to what NS Stream does. If we take a look in core, look at NS Stream. It has these functions: read, readable, write, writable. So it just deals with buffers of data. And if you would have a it would be possible. So you would make the request and then just have the data written to a stream. Yeah.
Okay,
yeah.
so basically,
it's not there yet, but it will be made.
okay, so what you're saying is basically you download the data and store it locally, but you don't process the data sequentially.
No, I'm saying that I didn't write it. I only wrote the uploading part, but the downloading part is similar. And you would need the did receive data. Is that the delegate? And then you just call write with lang, so data.bytes, data.length, and repeatedly call this. And then this is done actually in the app.
Okay.
Yeah. Anything else?
How large were the file streams? This was about the sizes.
Actually we didn't test with 100 megabytes, but we have had PDFs of over 10 up to 50 megabytes, and so not only uploading and downloading, but also rendering using CG PDF documents, something, and then a render page, so that it would, for every maybe that's a good thing to mention. In those cases, you need random access to the data, not streaming access. That's also in there. So then CG core data asks for specific ranges. Those ranges will be maybe processed through a logger or anything, and then at some point it comes to the crypto. Crypto will decide which blocks it needs to decrypt, look at the original file, decrypt it, and send it all back to CG drawing routines. Yes. Back.
It's really interesting, but have you thought of ways to concatenate different transforms? I can imagine when handling a large file for 100 megabytes, it takes some time to encrypt it or decrypt it, and then you might want to do something else with data, maybe on byte level. And it would save time if you can concatenate those different transforms or filter transforms.
Yeah.
So you have to iterate only once? Is that possible?
Yeah, indeed. So if I understand correctly, you would the whole operation of downloading it, decrypting it, you want to do it in one go. So as the first byte enters, it is processed, and before the last one comes through, it's already been processed. All the stuff. Yeah. That's the chain. The chain of operations. In a class, it's called NWO chain, where you can just add stuff to and just make it into one transform. But you can also just put them together. So, like you can see here's actually also already some chaining going on. I have a random stream, and then I use it as an input for the multi-part stream. So as the first random byte is generated, it's already going through the request. Actually, it's vice versa. The request asks for a little bit of data, and you can add anything in here. You can just, for example, if you want to deflate random data, it's not a good idea, but you can just do it by adding this one in here as well. It's a trivial exercise, of course. Right? So, this is all you need to do. And now it will send deflated random data.
Yeah, really cool. And you might even add there that it happens concurrently with different parts.
Well, yeah, the concurrency, talking about multi-threading and all that kind of stuff, which is built into this stream in some way, so you can schedule it on a run loop. That the whole run group scheduling and threads, and these operations become individual responsible for moving this data through. And the way it's set up now, it's more like just pulling it from one end, or pushing it from one end through the whole.
So I'm still not clear. So we have the random stream there. You get stuff. Apparently, you get stuff in that stream, and then when is that information sent to the next stream? Immediately, everybody.
Okay, just to be sure, this is the part where you configure the whole thing. Right? There's no data processed here whatsoever. That's the important part. You separate the declaration from the actual handling of the data, so you can just carry around access to a certain data source without actually carrying around all the data. It's just the potential to get this. Right? That's one. And secondly, where the question happens, well, this one is driven by the request, so the connection. So the URL connection will be the one asking for data, and then
pushing the pipeline
with a nice stack trace, it will just come all the way to RAM.
There was some talking about multi-threading. Just a short thing on that. Normally, the medium from where you put the data, be it disk or be it the web, that is usually your bottleneck. It's not the processing, the inflating or deflating. I think on the iPad. That's just my theory. My question was actually, if you didn't want to roll your own crypto stuff, how does it fit in this mechanism?
Well, the common crypto and OpenSSL libraries I've been looking at, they mostly support streaming cryptography.
Okay, so actually this does not include crypto, but
well, it does, but what I actually need to say is that doing crypto right, it's pretty hard, and I don't want to carry responsibility for your guys' security in the app. So if you want to do cryptography, it's just, well, if you're also, if you want to do that, then you're smart enough to make it yourself. Okay. But there is an example how to do crypto here.
Okay, so for example, you have a crypto transform in which you use a standard crypto library.
Yeah.
All right.
Yeah, that's what it does. But it becomes more tricky as you want to do random access, because then you have to start mingling with initialization vectors, line on the blocks. Depends if you want to do cipherblock chaining or output feedback, and that is all non-trivial, and I'm surely not an expert in that field. I'm still looking for a library that does all this, because it would be easy to integrate it. All you need is just like, okay, here's the next jump, or now I want to decrypt that